This video is for class 9 physics and we are doing spherical mirrors today. So we shall do spherical mirrors. Image formation of the spherical mirrors shall be discussed in the next video and their uses will be followed. Now spherical mirrors. A spherical mirror is made by silvering, that means making it opaque, a part of the hollow glass sphere. Thus a reflecting surface which is a part of a sphere is called a spherical mirror. So types of spherical mirrors, depending upon whether the inner or the outer surface of the sphere is silvered, spherical mirrors are two types, that is concave mirror and convex mirror. In figure 7.20, the right part of X of hollow sphere is silvered and coated on its outer surface and it forms a concave mirror, while the left part Y of the sphere is silvered and coated on its inner surface and it forms a convex mirror. So let us go to this figure 7.20. Here is our figure 7.20. So according to our paragraph, they are saying the X part, this part, the right hand side part, if it is being cut, right, this portion has been cut down and we silvered it, means we paint it with the silver color on this outer part, right, then thus this becomes opaque, this part becomes opaque, and thus this part can now reflect light, okay, and this becomes a mirror known as concave mirror, right. And now the part Y also has been cut down, where the silvering, that means the process of making it opaque, has been done from the inner side, okay, and thus whenever a ray of light strikes the mirror, it will get reflected. Thus this part becomes the reflecting part and this part becomes the opaque and the silvered part. So in case of convex mirror, so in case of concave mirror, it is just opposite. This part becomes opaque, that is the silvered part, okay, whereas this part becomes the reflecting part. So I hope you have understood how concave and convex mirrors are made from a hollow sphere. Now let us go to the concave mirror. A concave mirror is made by silvering the outer or the bulging surface of a piece of a hollow sphere such that the reflection takes place from the hollow or the concave surface as shown in figure 7.21a. Here this one, they are talking about this one, okay. So whenever the light rays strike this part, the reflection will occur, whereas in case of convex mirror, the silvering is done in the inner part and the reflection will take place from the outer bulging part. So whenever the ray strikes, okay, this part, the rays will get reflected. So that's what we had discussed, okay. Now I think we can go to the next topic also. Our next topic is a brief introduction of terms related to the spherical mirrors. The first one is the center of curvature. The first one is the center of curvature. If you remember, the mirrors were made out of the sphere, right, and this sphere should have a center as shown here in the figure, this sphere. Now as you can see, the concave as well as convex mirror is made out of the sphere and this sphere needs to have a center. This sphere needs to have a center. This center of the sphere is known as the center of curvature. So the center of the curvature of a mirror is the center of the sphere of which the mirror is a part, So we cannot see the center of curvature in reality, okay. It is the center of the sphere of which the mirror is a part, of which the mirror is made out of. We don't have total sphere with us, right. So therefore center of sphere cannot be seen in reality, right. So in figure 7.22 it represented by a symbol C, as you have seen. The normal at any point of the mirror passes through the center of curvature C. In other words, a line joining any point on the surface of a mirror to the center of curvature will be normal to the surface of the mirror at that point. It also means that suppose we have a mirror, or let me go to the black screen, okay, that will be helpful. Suppose we consider a concave mirror, right? Suppose we consider a concave mirror, right? This mirror is supposed to be made out of a sphere, and this sphere needs to have a center, right, whose name is center of curvature, right, whose name is center of curvature. Now suppose I draw one line from the center of curvature, right. This line always makes 90° with the curved mirror, right. Only this line, any line coming from the center of curvature strikes the mirror, always makes 90° with the surface of the mirror. Not any line, okay, only this line, right. So a normal can be drawn for this particular mirror, right, whenever a line is passing through the center of curvature. So a line joining any point on the surface of the mirror to the center of curvature will be normal to the surface, means it makes 90° with the surface. So I hope you have understood the center of curvature. I hope you have understood the center of curvature. Now coming to the next part, that is the radius of curvature. Radius of curvature of a spherical mirror or any concave or convex mirror is the radius of a sphere of which the spherical mirror is a part, is called the radius of curvature of the mirror, or in other words I can say it is the distance between the center of curvature and the pole of the mirror. Is the distance between the center of curvature and the pole of the mirror. This distance is known as the radius of curvature, which is shown by the letter r. Now the question comes, what is the pole of the mirror, right? What is the pole of the mirror? This radius of curvature can be any line joining the center of curvature and the mirror. Any line, right? Any line joining the center of curvature and the mirror becomes the radius of curvature, because this is the radius of the sphere of which the mirror is a part. Now going to the next point, which is the pole of the mirror, right? The pole of the mirror is the geometric center of the spherical surface of a mirror, right? Now the difference between pole and the center of curvature is that the center of curvature is the center of the sphere, the whole sphere, whereas the pole is the geometrical center of the mirror. So if you go to a real picture of a mirror, a concave mirror, so here is a picture of a concave mirror, right? So if I want to mark the pole of the mirror, it will be somewhere around here, but I cannot mark the center of curvature, right, because it is lying outside your screen this time. So this is the pole, right, of the mirror. It is the geometrical center of the mirror. So I hope you have understood what pole is. Now the next point is aperture. The plane surface area of the mirror through which the light rays enter and fall on the mirror is called the aperture of the mirror. Now if you want to see in the figure, right, so let's go to the figure here. This portion here, this portion from here to here is the aperture. This portion from here to here is the aperture. Aperture is the surface area of the mirror on which the light rays can strike, So this becomes the aperture of the mirror. And now the next point is the principal axis, okay. It is the straight line joining the pole of the mirror to its center of curvature. Like radius of curvature was the line joining the center of curvature and the pole, right, or any line joining the mirror, any point on the mirror and the center of curvature, but the principal axis is a special one. It is a straight line joining the pole of the mirror and to its center of curvature. So only one line, like for example, when I was explaining the radius of curvature, I could have drawn any line from the center of curvature, any line from this line or this line, they all become the radius of curvature. But the principal axis is the line joining the center of curvature and the pole of the mirror. This particular line is known as the principal axis. So I hope you have understood what principal axis is. So now reflection of light ray from a spherical mirror. So from a spherical mirror, reflection of light follows the same laws of reflection as in the plane surface. That is, the angle of incidence I is equal to the angle of reflection R, and the incident ray, reflected ray and the normal should all lie on the same plane at the point of incidence. Note, in a spherical mirror, to obtain the direction of the reflected ray for a given incident ray, first draw a normal at the point of incidence. For this, draw a line joining the point of incidence to the center of curvature, because we had discussed that any line passing through the center of curvature and touching the mirror should be the normal to the mirror. Then draw the line on the other side of the normal, making the angle, that is the angle of reflection, equal to the angle of incidence. This line represents the reflected ray. Here we shall not use this concept while drawing the ray diagrams, because it will be too lengthy. We shall not use this. Okay, we shall skip this, right? We shall not use this, not use while drawing ray diagrams. Right, otherwise it will be too lengthy. Okay, but in reality this thing happens. So example, in figure 7.23 we are to find the direction of reflected ray for an incident ray AD on a concave mirror and a convex mirror, for which C is the position of the center of curvature. Now here if you want to follow that particular rule, okay, so any ray incident on the mirror, right, should be reflected. So this black colored ray represents an incident ray. So my job is to draw one normal passing to the center of curvature at the point of incidence. Then measure this angle. Suppose this angle is 10 degree. Again, with the help of protractor, use measure 10 degree here, right? Then only draw the reflected ray. Okay, this what the note says. So any incident ray on the convex mirror, right? Then what I am supposed to do is I need to draw one normal passing through the point of incidence and the center of curvature, right? Thus I will get a straight line and measure this angle. Suppose this angle is 50 degree, right? Again measure here 50 degree, then only draw the reflected ray. But this rule we are not following. Okay, this happens in reality. Okay, but this rule we are not following while drawing the ray diagrams. So I hope you have understood, right, what we should do and what we should avoid to do, right? The next term which is given to us is focus and focal length. Focus. Now focus we have to study separately for concave mirror and separately for convex mirror. So let us understand focus first, then we can easily understand focal length. Now for concave mirror, let us go to the figure for concave mirror. So then we can go to the definition. For a concave mirror, suppose the rays, the incident rays are parallel to each other, okay, and parallel to the principal axis also. Then what happens after reflection? You can see after reflection they will all pass through a common point on the principal axis. Let me change the color. They'll all pass through the common point on the principal axis. This common point is called the focus, right? So the definition of the focus for the concave mirror shall be, if the rays are incident parallel to the principal axis on the mirror, then after reflection all these rays meet at a point, and that point on the principal axis is known as the focus, right. So here the focus of a concave mirror is a point on the principal axis through which the light rays incident parallel to the principal axis pass after the reflection from the mirror. So I hope you have understood the principal focus or simply focus for the concave mirror. Now let us try to understand for the convex mirror. Now trying to understand this term focus for convex mirror. Similarly, like concave mirror, if the rays are parallel to each other and then parallel to the principal axis also, right, then when these rays are incident on the mirror, they will suffer reflection, right, such that the reflected rays, the red rays here, will appear to come from one point, from the principal axis, and this point on the principal axis where the rays appear to come from is known as the principal focus or simply focus for convex mirror. Now let us see the definition. The focus of a convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to come after reflection from the mirror. So I hope you have understood this focus for convex mirror as well as for the concave mirror. Now going to the next term, that is the focal length. Okay, focal length is the distance measured between the focus and the pole, right. It is denoted by small f, whereas focus is denoted by capital F. So I hope you have understood focal length is the distance between the focus and the pole of the mirror. Now one more thing, I think you have observed that in this particular mirror the rays were going away from each other, that means we see they are divergent rays. So here due to this fact that this particular convex mirror diverges the light coming to it, so it is also known as a diverging mirror. Whereas if you have noticed in concave mirror that the reflected rays converge to a point, that the reflected rays converge to a point, converging rays here. So this kind of mirror which can converge the beam of light is known as converging mirror. Here also the focal length will be the distance between the pole and the focus, and this is converging mirror because it converges light, whereas the other one, that is the convex, is the diverging mirror because it diverges the light. So I hope you have understood the terms focus and focal length as well. So now going to the last part of the video where we need to discuss last term, that is known as focal plane. Let us try to discuss focal plane. Look, when we were describing focus, right, we assume that the rays are parallel to each other and also parallel to the principal axis. That was our criteria. Okay, but it is not necessary in reality that the rays are parallel, and it needs to be parallel with the principal axis also. The rays might be parallel but not parallel to the principal axis. So a plane passing through the focus and normal to the principal axis of the mirror is called focal plane. I have to explain this particular statement, right. To explain this particular statement, let us go to this figure. Okay, now you can observe here the rays are parallel to each other, the incident rays are parallel to each other, but they are not parallel to the principal axis. So what happens in this case? These rays will tend to meet at a point again, but just below the focus. This is the focus, just below the focus is tend to meet. So you can see there is a line here which joins this focus and the point where they are meeting. Okay, if you can imagine this particular line in a 3D picture, then this line will change into a plane, that is area. Collection of lines becomes what? Area, right. So any flat area passing through this focus such that it is perpendicular to the focus and the principal axis. Okay, like for example, a line is going here, this is the principal axis. We can imagine one surface, such that this surface is 90 degree, such that this surface is 90 degree with the principal axis, as well as it is passing to the focus, perpendicular to the focus as well. So this particular plane, this particular paper or any flat surface can be considered as focal plane. Can be considered as focal plane. So focal plane you can imagine as a paper, right, kept normally, that means perpendicular to the focus on the principal axis, right. So therefore we will say that this particular rays are meeting at the focal plane. So I hope this is clear. Now a plane passing through the focus and normal to the principal axis of the mirror is called the focal plane. Remember, they are all imaginary. Okay, a parallel beam of light incident to the principal axis get focused at a point at this plane, and figure 7.26b, which we will discuss later on, it is the point where the rays passing through the center of curvature meets the focal plane. So let us go to that figure here. This is for the convex mirror, the focal plane for the convex mirror. Now again, when we were describing the focus, the rays were parallel to each other and it was parallel to the principal axis also, but it is not necessary, right. So here what happens, the rays are parallel but not parallel to the principal axis, and they are incident on the convex mirror. So what happens is the light will try to diverge, go away from each other. Thus when we produce them backwards, they tend to meet at a point just above or below the focus. In this case they are meeting at a point just above the focus, right. So this point here, right, okay, so this point here lie on a plane surface, this surface, which is perpendicular to the principal axis, and it's passing to the focus. So similarly as in case of concave mirror, right, but here the rays are appear to come from this point. Okay, they are appearing to meet at this point, the reflected rays. So this plane here is known as the focal plane for convex mirror, and we say that the rays appear to come from a point, from a plane, and which plane? Focal plane. So this much for this video. Okay, I hope you have understood focal plane and focus. If you have any questions, you can always ask in the Google Meet. Okay, thank you so much.